Friends, let's learn Coulomb's law using Gauss theorem. This means that we are going to find or derive Coulomb's law using Gauss theorem. For this, we require a charge plus Q. Let us have a charge plus Q. This plus Q charge will produce electric field around it. So due to electric field, if we imagine a Gaussian surface or hypothetical surface, then there should be electric flux. So let us imagine here a Gaussian surface of radius r. Then we have, this is the Gaussian surface. Gaussian surface. Spherical Gaussian surface. So we have, let us take here a small surface area ds. This is ds, small surface area, along which electric field is E from the charge. This is the electric field. So we have, according to Gauss law, flux phi is equals to close integration E dot ds, which is equals to Q upon epsilon naught. Now you are saying that E and ds have angle theta is equals to 0 degree. So we can write here close integration E ds cos 0 degree is equals to Q upon epsilon naught. Cos 0 degree is 1. So you have E close integration ds is equals to Q by epsilon naught. Here ds is a small surface area on the sphere. When it is integrated for the whole sphere, you get the surface area of a sphere, which is 4 pi r square. So you have electric field E into 4 pi r square is equals to Q upon epsilon naught. Thus, you get electric field E equals to 1 by 4 pi epsilon naught Q upon r square. Here you get electric field using Gauss theorem. Now let us place a charge here. This is known as Q naught charge. Then this charge and this charge will repel. This repulsion produces a force F. And force F is equals to Q naught into electric field. You know that. So we have force F is equals to, we know force F is equals to Q naught E. Let us place the value of E. What is the value of E is 1 by 4 pi epsilon naught Q upon r square. So what you get? You get 1 by 4 pi epsilon naught Q naught upon r square. This is F. This is said to be Coulomb's law, which we have deduced using Gauss theorem. Now let us have numerical based on this. Let us have numerical. In this numerical, I am giving you a plus Q charge. Let us have a plus Q charge. This plus Q charge produces electric flux phi is equals to 8 pi 10 to the power 8 voltmeter at a distance r, which is r equals to 1 millimeter. Then what will be the force on a charge Q naught equals to 1 microcoulomb when placed at the distance r? You have to find the force F. What is the force? Then this type of numerical can be solved by two formula. One is said to be Gauss law, other is said to be Coulomb's law. So first we use Gauss law. According to Gauss's law or theorem, you have phi is equals to Q upon epsilon naught. The value of phi is given. The value of phi is 8 pi 10 to the power 8. This is Q upon epsilon naught. So you have Q equals to 8 pi epsilon naught 10 to the power 8 Coulomb. You get the charge. Now according to Coulomb's Coulomb's law, you have force F is K Q naught upon R square. So let us place the value. So what is the value? Let us place the value. F, value of K is 1 upon 4 pi epsilon naught. Value of Q, here you have find the value of Q, which is 8 pi epsilon naught 10 to the power 8. And value of Q naught is given in the question, 1 microcoulomb. This means that Q naught equals to 1 microcoulomb. This means that 1 into 10 to the power minus 6 coulomb for micro. So you have 10 to the power minus 6 here. Distance is 1 mm apart. R is 1 mm. This means that 10 to the power minus 3 meter. So right here 10 to the power minus 3 whole square, because there is R square. Now just solve it. Here you have epsilon naught cancel out, pi cancel out, 4 cancel to 8, you get 2 here. So you have 2 into 10 to the power 8 into 10 to the power minus 6. In the denominator side, 3 into 2. This is minus 6, this will cancel out. So you get 2 into 10 to the power 8 Newton. Thus you get the force. This numerical are using two formula known as Gauss law as well as known as Coulomb's law. Thus you are enjoying physics. Okay, so do like, share, subscribe my channel and also give your comments. Thank you.